In this lesson, we'll start a three-part series on uses and abuses of percentages. So this is part one. What we'll do is we'll talk about some common misunderstandings and misconceptions about percentages, and then we'll apply our understanding of percent to various application problems. Recall in the previous lessons that we talked about part percent whole, and then we also talked about absolute and relative change and percent increase and decrease. So we're going to build on that understanding in this three-part series as well. Okay, so talking about percent versus percent increase and decrease, so bringing the last couple of lessons together. And I'm just going to talk through these points. You may or may not want to write them in your notes or may want to summarize it somehow and not write necessarily every single word. So on the left column, talking about percent of a number. So if we say 100% of a number, it means that the original number has stayed the same. So if I were to tell you I have 100% of students attending my classes, that means everyone is still here. If we have something less than 100%, means that the original number has decreased. So if I say I have 80% of students attending my classes, that means that what I had at the beginning has gotten smaller. More than 100% of a number means that the original number has gotten bigger. So if I say I have 150% of students attending my classes, maybe a class got canceled and I gained more, but that number has gotten bigger. Okay. When we talk about percent change, this is talking about relative change or percent increase, percent decrease. So in this type, depending on the wording, 100% increase, so notice this is increase, this is of, means that the original number has doubled. So for instance, we'll use my dog. My puppy's weight has increased by 100% since she was 6 months old. She was 7 pounds and now she's 14 pounds. So notice how that's doubled. An increase more than 0% but less than 100 means that the original number has increased but not necessarily doubled. So for instance, my puppy's weight has increased by 60% since she was 10 months old. She was 8.75 pounds, now she's 14 pounds. So there's a bit of an increase, but it hasn't necessarily doubled since she was 10 months old. And then a decrease of more than 0% but less than 100 means that the original number has decreased but hasn't necessarily reached zero. So my puppy's weight has decreased by 30% since January. She was 20 pounds, now she's 14. We stopped feeding her holiday food. Okay, so notice it's a small word, but it turns on if we're talking about percent of or percent increase and decrease. So also notice here that when we say 100% increase of a number means the original number has doubled, that means that a 200% increase would mean the original number has tripled, and so on and so forth. Okay, so identifying misconceptions. So again, just kind of a better table, and we'll use a different example. Percent of is usually dealing with a ratio or a fraction. So if you get 80 questions right out of 100 on an exam, that means you got 80% of the questions correct. Percent increase or decrease by a specific percentage is more talking about relative change when we're using a given value and comparing it to a previous value or vice versa. So another example, a $10 item increases in price to $20. So there's two ways to describe this change in talking about percentages. We can talk about percent of. So the new price is 200% of the old price. And to get that, we would set up our fraction. 20 over 10 is 2, and then times 100% would give us 200%. So that's why you can say that the new price is 200% of the old price using of or a fraction or ratio. The second way to describe it is percent increase. So the price increased by 100%. So when we're talking about this, we would take our new minus old divided by old times 100%. And that's what I have written here. And this would give us 1 times 100%, which means 100% increase. So be careful, not only in the math problems, but when you're talking about percentages as well, what you're saying and what you're meaning. So do the following problems make sense? So talking about what we just did with percent of and percent increase and decrease, can I say these following statements or do they make sense? So number 1, the price of tuition has tripled since my parents went to college. That's a 200% increase. Yes, this statement makes sense. A 200% increase means that the original number has tripled. If your salary is 15% more than mine, then I make 15% less than you. Let's try this out. let's say my salary, for sake of ease, we'll use 100,000, and your salary is 15% more, which would be 115,000. Okay. So now we need to determine if it's true that I make 15% less than you. Okay, well, 15% less than 115,000, we can take 115,000 as our whole, 15% as our part, and plug it into the calculator. And then 17. So 15% of 115,000 is 17,250, and so we would subtract that from 115,000 to get, this would mean that I would make 97,750, which is not the case. So percentages don't work both ways. This statement does not make sense. Okay. Number 3, the rate on our fund increased by 50% to 12%. Okay, this statement would make sense. If we started off with 8% with a 50% increase, 50% of half of 8 is 4, which would give us 12%. So ratios and percent. So a ratio is a comparison between two values, and we can express ratios as percentages. So example 1, let A equal 8 and B equal 24. Find the ratio of A to B. A to B means we would take 8 over 24, and we could reduce this in our calculator later to 1/3. Part B, find the ratio of B to A. So now B would go in the numerator, A would go in the denominator, and this would reduce to 3. Part C, A is what percent of B? So A is the numerator, B is the denominator. We found that this is 1/3, so we would divide the two and multiply by 100. I didn't tell you where to round, but let's go to 1 decimal place. B is what percent of A? So we would take 24 over 8, which is 3, times 100%, which would give us 300%. So that's just some practice with expressing ratios or two values as a percentage. Example 2. What percent of nuclear weapons does the U.S. own if the U.S. owns 10,000 and the estimated number of nuclear weapons worldwide is 27,000? Round the percent to the nearest tenths place. So we're finding the comparison of how many nuclear weapons the U.S. owns to how many nuclear weapons there are worldwide. So we can set this up as 10,000. This is the U.S. This is world over 27,000. Okay. And I'm going to divide these two, and I'm going to write a lot of numbers after the decimal to talk about how these should be rounded. So this is 0.3. And the pattern probably continues. Now, when we're writing this number as a percent rounded to the tenths place, you round once you convert the decimal to a percentage. So for instance, we don't round here and say 0.4. We make this a percent, so this would be 37.0370%, and now we're going to round to the tenths place. We look next door. The number to the right is 0 to 4, and so this stays the same as 37.0, or just 37%. Okay. Example 3, express the first number as a percentage of the second, round the percent to 2 decimal places as needed. So the 2019 revenue for Samsung was $206 billion compared to $260.2 billion for Apple. Now you can write these numbers out. So for instance, $206 billion, I'm just going to write it at the top, billions, millions, thousands, hundreds, and divide. But all of those zeros will eventually cancel. So for this type of problem, you can do 206 billion divided by 260.2 billion. Which will give us 0.79169, and keep going. And remember, we round after we convert the decimal to a percent. So this becomes 79.169, and then rounded to the tenths place, the number next door is 5 through 9, which causes the value in the tenths place to go up 1 to get 79.2%. Part B, the 2020 population of Las Vegas is 200,699,000. The 2018 population of Las Vegas was 2,541,000, and so we're expressing the first number as a percentage of the second. So we would do the 2020 over the 2018. Okay. And so put this in your calculator to get 1.06218 and so on. Convert it to a percent. And it makes sense that in this case, the percentage of is more than 100 because the value, the current value that we're using is bigger than the denominator. And then this rounded to the tens place is 0.2. Okay. Thank you for watching. We'll continue our discussion of uses and abuses of percentages in the next 2 lessons. If you have any questions, please feel free to reach out to me.